Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to sample problem on modeling of electrical system, which is question number 2. So, for this question, you are given this figure, which is an RLC circuit that are connected in parallel. And you are given here the current source. Okay, so the symbol here is for current. Now you are asked to determine the differential equation that represent this system. Okay, so for this circuit, you can apply the Kirchhoff's current law to solve the problem. Okay, so here we have the current flowing this way. So this is x of t. When it reaches this junction, let's call this junction number 1, okay, this current will be divided into two parts. This one and the one that goes into the resistor. Let's call this I1. Okay, and let's call this IA. Now when this IA reach this junction number 2, it will again divided into this current, and the current goes into the inductor. So let's call this I2 and let's call this I3. So if we do a summation of current for junction number 1, we have x of t, which is the current going into the junction, equals to IA plus I1, okay, which is equals to the current going out from the junction. Okay. For junction number 2, we have IA equals to I2 plus I3. Okay. IA going into the junction, I2 and I3 coming out from the junction. Okay, so if we substitute this IA into here, then we will get I1 plus I2 plus I3 equals to x of t. Okay. So again, here we already have an equation, but this equation is not a linear differential equation. Okay, what we want is to represent this system by a differential equation. Right, so we can do that by looking back at our slide here, okay, where we have this table that gives us the relationship between current and voltage for capacitor, resistor and inductor. Okay, so if we substitute this into the solution here, okay, where I1 is the resistor current, I2 is the capacitor current, I3 is the inductor current, and we are also given this y of t here, which is voltage. So we can find the relationship between the current and the voltage y of t. Okay, so if we rewrite this equation, we will have for I1, which is the resistor current, dx of t for the resistor current, it's 1 over R y of t plus c dy of t over dt plus the inductor current in terms of voltage it will be integration from 0 to t y tau d tau. This one equals to x of t. Okay. So again, here we have an integration. Okay, so we want to eliminate this integration. Using differentiation, okay, d over dt. So if we differentiate this, the whole equation, say equation A, we will get a new one. This one is y of t. So if we differentiate, we will have 1 over r dy of t over dt, plus this one first order differentiation, it will become second order differentiation. And this one, the integration is eliminated, so you will left with only y of t equals to dx of t over dt. So next we can rearrange this to make it looks like the standard form of differential equation. So we have c d square y of t over dt square plus 1 over r dy of t over dt plus 1 over l y of t equals to dx of t over dt. So this is the differential equation that represents the RLC circuit over here. Okay, so that's all for this video. Thank you.